Let's go. Yeah. Our project is about Circom-TFHE, and the Circom-TFHE is an integrated version of Circom and SPTG toolkit which developed from somewhere. And our team name is Mizuki-chan Aishiteru. So Mizuki-chan is the girl in the background, and Aishiteru means I love you in Japan. So what is Circom-TFHE? So our project was based on this tool, and this tool is changing Circom to MP-SPTG. So that means that as everyone knows, Circom is a writing or language or framework for writing CK circuit, and MP-SPTG is somewhat kind of new, and this is a framework or language for writing MPC circuit. So one can just name this as a circuit, or one can just say as a program. Anyway, this is MP-SPTG, and the framework which named Circom MP-SPTG is that there is a Circom CK circuit, and we can make that Circom circuit to converted version of MPC by running the Circom circuit. So this is somewhat wrong. Actually, the better expression than running is something like converting. And anyway, this is a principle that Circom SPTG, MP-SPTG work. So there's a Circom circuit, and using another tool named Circom-TFHE, we can make a circuit named Bristol. So Bristol circuit is some kind of like an intermediate circuit that can make some circuit as some kind of text. And if we make this Bristol fashion circuit, we can convert this Bristol fashion circuit to the MP-SPTG circuit. And also we have some information about circuit, and that is named circuit information JSON. And this includes some data. So as you know, in circuit there's some wire and something like that, and the circuit info.json have a role with mapping that wire and variable name. That is what the circuit info JSON does, and this is the Bristol to MP. So taking some procedure like Bristol to MP-SPTG circuit, we can make that MP-SPTG circuit. And there are also MPC settings.json, and the thing that is needed is something like in MPC there are multiple parties, so this JSON has some information about this MPC. And our work is to remove MPC and add TFHE. So I'll briefly explain what the TFHE or FHE is. So FHE is fully homomorphic encryption. So someone can would be curious about why there's a word fully. So the reason of the word which named fully exists is something like in somewhat basic homomorphic encryption scheme. In almost every scheme in FHE, there is a term named noise, and if you do some operation like this operation, the noise gets grow. And if the noise grow, we cannot guarantee the correct operation. So that's why we should do some operation like bootstrapping like that. And with the bootstrapping or something like that operation, we can add a word fully. So if in the FHE, almost infinite number of operations are allowed, but in something like somewhat homomorphic encryption or just a homomorphic encryption, just the limited operation is always supported. So anyway, fully homomorphic encryption means like this. So there is an X and Y, and if we encrypt it, and if we add it, and if we decrypt it, the original value gets if we do that operation inside of this encryption operation. So the field is totally different. So if we do a add operation in the X and Y field, it is okay, but it's also okay that we can do a add operation on encrypted space. Anyway, multiplying operation is also allowed. And yeah, the reason we define the fully homomorphic encryption like this is because something like encryption or decryption should be deterministic, but encryption algorithm or function can be probabilistic. So that's why we can defined like this. If we define an encryption function as a function, it is wrong because it is somewhat probabilistic. And the TFHE is something like one of the scheme in FHE, and encryption decryption is similar for the most famous scheme in FHE, which named BFB scheme, but the difference is in bootstrapping. So what is Circom-TFHE is that we can you can remove that MP-SPDG to TFHE. That is all about it. And the working procedure of this is something like there is a Bristol format circuit that is converted for the Circum circuit, and there is also circuit information and there is an input. So using these three operations, we can make a TFHE circuit. So we can generate a circuit and we can run that. So that is all. So we have a steps that first step is making a Circum circuit, and second is convert Circum to TFHE RS program. In here, as I've said, we can convert Circum to Bristol circuit, and then we can convert Bristol circuit to TFHE RS program, and we can run that program. And there were some issues. That first issue was that kind of variable size. So in the reason that variable size is pretty important is that in TFHE or some kind of another FHE scheme, just a single bit or some small size of variable gets pretty large when we encrypt it. So that's why we should, if we can, we should limit the variable size. So, but if we just convert that Circum circuit into the TFHE, we cannot easily determine the variable type. So that is the variable size is important, and we just done this. The program we made is something like an initial stage, so we fixed all of the variable size. And the second issue was input type. So what the input type means is something like public and private input. So in Circum circuit, there is a public and private input. Then in TFHE program, how can you deal with this public and private input? It was pretty important. So the method that we've done is something like there is two operations in FHE. So in TFHE RS framework, we can just add or multiply with the normal variable and encrypted variable. So we can see that means that in the binary operation, we can also do operations with not encrypted variable and encrypted variable. So we made all public input as a non-encrypted variable, and we made private input to all encrypted variable. And that is how we've done with this input type. And the limitation was that TFHE doesn't support the exponent operations, and there are a lot of operations that TFHE does not natively support, and this was the limitations. Thanks for watching. Yeah.
Okay, next one. Yeah, so when we generate a circuit and the circuit converts into the TFHE RS, the arithmetization happens in between that, right?
Yeah, arithmetization happens in TFHE RS.
Okay.
If there's no question, I will end the presentation. Yeah.